There are 3.
Oh, one more.
Yes. So if you're online and you have any questions at any point, just put them in the chat and we're monitoring it and we'll ask them for you. So I guess we'll go ahead and start. Thank you for joining us, both in person and virtually. We're going to, Dr. Wang is going to present a talk on machine learning today, the analysis of qualitative and quantitative data. Dr. Wang is an assistant professor of finance at VSU. He is SAS certified in machine learning as a specialist. He is currently teaching financial management, which is FIN 3350, and also modern financial intermediaries and risk management, which is FIN 4760. So if you're interested in taking any of those courses after this discussion, highly recommend. And Dr. Wang, would you like to take over?
Okay, thank you very much for coming to the speech. I really very appreciate it. For today's speech, I want to talk about the application of machine learning in data analytics, because like our club or association is about data analytics. So I want to discuss the application of machine learning in 2 aspects in this area. One is about quantitative data, which is very straightforward because we use quantitative data, numbers, ratios, like in business area a lot. Okay, and I also want to discuss the applications related to qualitative data, or in other words, text data. Okay, so for example, like the Word documents, how could we convert those information to numbers and then complete the data analytics work? Okay. Okay, so here's a little bit more details about myself. So I'm currently assistant professor of finance at the VSU. I got my PhD degree from Michigan State University, major in finance. Before that, I got a Bachelor of Science in business management, like from SUNY Stony Brook in New York. And then I went to Georgia Tech to get my financial engineering master degree. Okay. Before my PhD life, my research area includes several aspects. For example, fintech, machine learning, and also corporate finance and banking. So basically, I'm focusing on the intersection of multiple areas, including finance, accounting, as well as the machine learning things. Okay, I used to work in commercial banking area as well as a futures brokerage company, and I like travel, paintings, different sports, like for spare time. Okay, so before talking about the machine learnings, like let's discuss some major challenges existing in today's real industry. Okay, so in my opinion, there are majorly 3 challenges, like in current data science area or business analytics area. The first is the huge amount of information, okay? Because the technology is developing, like continuously, we have more and more available information, like in the market. Okay, for example, we can post information on Twitter. We can include any messages, like in some news or online postings. Those are all information. Okay, so when doing the trading, like in the stock market, we know that we need the information to help us to make a decision about buy or sell or do forecasting work on a stock price or other aspect of the market. But there is a huge amount of information in recent years, okay? Especially available through the internet. Okay? So make human beings hard to analysis or to do the analysis considering all details. For example, like when doing the trading, probably you may have like 1 minute or 5 minutes time to make a judgment about your investment, like decision sometimes. But there are like thousands or millions of messages like in the market, like during this certain time period, like based on like, human beings, I mean the ability of human beings, it's impossible to digest all the information within a certain time period. Okay, even we can do it within 1 year or 2 years, but within a certain time period like a couple of minutes, it's impossible. Okay, also. In recent years, we find that because of the huge amount of information, it's becoming harder to use traditional econometrics model to do data analysis. Okay? For example, like especially dealing with the big data. Okay? So it's quite hard to imagine that we need to use like linear regression to like do data analytics, like involving a huge amount of data, okay? And also like still like some qualitative information cannot be applied in quantitative analysis. Okay, we can use numbers like or like use numbers as input for the models, but it's quite hard to put text into the model to do forecasting work. Okay. So basically. Because of those challenges, like a data scientist or like a specialist are developing the new generation techniques, okay? Including like artificial intelligence or including like machine learning also. Okay, so we can rely on machine learning techniques to deal with those information for us. Okay? If the ability of the human beings is quite limited, we can use machine to help us to do the data analytics work. Okay. So machine learning is a study of computer like, algorithms that can improve automatically through the experience and by the use of data. Okay. Some machine learning techniques do not rely on the manual modifications or like a manual process from the human beings. They can improve the model by themselves. Okay. Some other techniques may not be that convenient, and people or human beings need to put into some initial settings, and then like further develop the model. Okay. So how does the machine learning work? Basically, we first input data, and then analyze data, find the patterns, and then do the predictions, and then store the feedback, like locally. Okay. So basically, at the very beginning, like literally, I will provide an example about the algorithm or principles behind machine learning. Now, why we call it a learning process? Okay, it's because we have an initial setting, and then by input more and more information into this initial setting, and we can get a better and better models for a certain topic. Okay, gradually, and the more information involved in the machine learning algorithm, the better. Okay. So there are two major, in fact, there are many like aspects that we can apply machine learning techniques. But in business area, like I divide the current application of machine learning into two major aspects. One is the forecasting work, Okay, this part is majorly related to the quantitative data. Okay, so is for forecasting work, basically machine learning techniques can provide a more sophisticated model structure, and generally they can provide a better forecasting power on a certain topic. Okay, so basically, for example, like we have some very important or popular areas that have applied machine learning a lot. For example, like a price prediction, like a stock price prediction, or we call asset pricing. Okay, so what's the trend of a certain stock in the future? Basically, we can use machine learning techniques or algorithms to construct like a price or return forecasting models. Okay, and this part or this area is a very large part of the whole literature, like in business area, because when machine learning techniques becomes popular, many people like have tried it first for making money, okay? Starting from as early as 2011, basically there was a paper in finance, like in 2011, starting to use machine learning techniques to do some factor models construction, okay, or asset pricing model construction, okay. And also, like we can do some like credit rating forecasting work. For example, like we can predict the probability of default of a firm. Okay, what's the likelihood that a certain firm will go default or like will survive? Okay, or what's the probability that a firm will have a rating upgrade or rating downgrade? Okay, and also like we can use machine learning to do foreign exchange rate prediction, okay, as well as the financial analyst recommendations. Okay, so basically, like we have a lot of financial analysts, like working in like a brokerage, like and they are providing like stock recommendations, like you need to buy a certain stock now or you need to sell it now. And machine learning can first, they can help financial analysts to make that decision or to make that judgment. Second, machine learning can also predict the forecast of the analyst. Okay, if you put enough like input variables or information. Okay. And also it can detect the fraud or financial misconduct. For example, like what's the likelihood that the bank will be involved in a financial misconduct or a fraud action or some other bad things, like based on the financial statement or based on the annual report of the firm, okay? As well as bankruptcy. What's the likelihood that a firm will go bankruptcy in the future? And even in corporate finance, like there are some machine learning methods that can help people to make a decision about board members or board directors of a firm. Okay, and also there are many other aspects. Basically, like for if we need some like forecasting model or prediction models, basically we can rely on or we can apply like machine learning techniques or algorithms. Okay, almost for all the prediction works. Okay. Here is an example about the application of machine learning in asset pricing area. Okay. So for example, we have a group of asset pricing models. In fact, we have thousands of them, like in current industry, like from CAPM, okay, to Pharma French 3-factor models, to Pharma French 5-factor models. And until now, like we have thousands of them, okay? But some of them may have a very good performance during a certain time period. Some of them may have better performance in the past, but those models can be quite hard to have a consistent performance, like in a very long time period, for example, 10 years or 20 years. It's quite hard to have a good, or to keep a good performance for a time horizon like 20 years, okay? So how to deal with this issue, okay? We can apply like basic machine learning techniques, which is called Bayesian model averaging, okay, to more or less solve these obstacles, okay. For example, we have n models at the very beginning, okay. For maybe model 1 is CAPM, model 2 is the Gamma-French 3-factor models, and those are all the models to do stock price forecasting work. Okay, some of them are good models, some of them are horrible models. Okay, and n can be hundreds or thousands. Okay, and at the very beginning, we can assign an equal weight to each one of them. Okay, equal weight like for the initial setting. Okay, and we use the sample data for a certain time period to train each model in our model set. Okay, and then to use those models to check the performance of the models one by one, and then rank the performance, rank those models from good performance to bad performance, like one by one. Okay, and then we have a list of a model from the best performance to the bottom performance, right? And based on this ranking, we can move more weight to the good performance model and reduce a certain amount of weight for the worst performance model, and then do the complete adjustment of the weight automatically. Okay, so for example, like the top one model may gain like a 50% weight. A worst model will reduce 50% like a weight, like in the algorithm. Okay? Or like for the second ranking model may increase 40%. Okay? We have those initial like algorithm at the very beginning. Based on the rankings, we adjust the weight from equal weight to like a various weight across different models based on their rankings. And then we go back, move the sample period 1 year further, redo it, okay? Redo it, and then re-rank the model again for new sample or for 1 year new sample, okay? And then adjust the weight again, okay? Not starting from the initial like equal weights, but starting from the last weight allocations. Okay, starting from the last time, and we adjust the weight again based on the new performance, and then we generate a set of new weights for each model in your model pools. Okay, and then we repeat this loop again and again by adding more and more new data. Okay, and once we have like a certain length of the time period input in this loop, then once we reach to the end of the time period, we can generate a pool of model with like a specific weights on each one of them. Okay, and then we can use all the models to do a forecasting work and take the average or take the weighted average using the latest weight we have, like just coming out of the loop. Okay, so this is an example about like a machine learning. That's the reason why we call it learning, is because we use the past data and then adjust the the weight of all the models, and then we start to input more and more data and to learn through this algorithm. Okay, and then in the end we generate a Bayesian model averaging algorithm result. Okay, and generally from the research result, this Bayesian model average model can outperform most of the models in this pool. Okay, because we are getting rid of the worst one, and we are putting more weight to the best one. Okay. This one I will keep it to the end if we still have time, because this is about the deep neural network. Okay. And this graph is from one of my paper. Okay. So we'll talk about that later. So Bayesian model averaging is a basic application about machine learning algorithm. Okay. So basically we have more advanced machine learning algorithm nowadays, but the basic principles behind is similar. We are using the past data or past information to learn through the algorithm. Okay. And those are the application about the application of machine learning on the quantitative data, because those input are all numbers. Okay. Input in the asset pricing model are generally all numbers, like the financial statement data or accounting data, like total asset or current asset or the size of the firm, those kind of data. Those are all numbers. But another popular application of machine learning in business, or more specifically finance, is data generation. Okay, data generation. So machine learning or artificial intelligence provides people an access to a larger information set. Okay, we can use those algorithms to convert text or words data to numbers. Okay, and which will provide us more information when doing data analytics. Okay. So it is closely related to textual analysis. Okay. For example, calculate the sentiment of a certain document. Okay. Or calculate the uncertainty involved in a certain document, or the confidence or the topic allocations of a certain document. Okay. So the reason why people are using those algorithms a lot recently, because we have a lot of tax information available online now. For example, through SEC or Securities and Exchange Commissions, that we can access to the firm's SEC filings for free. Okay, those are all publicly available information, including the annual report of a firm, quarterly report of a firm, or different other filings, for example, S1, which is about IPO of a firm, okay, or 8K, which is about the significant events relevant to the shareholders. Basically, publicly traded firms need to include those information and submit those information to SEC through 8K filings. Okay, and we have a lot of them. Okay, a lot of them. And also we also have other tax information sources. For example, the financial analyst reports. They provide a suggestion about buy or sell, but we have a very long document sometimes, and we can dig more into the document about the information included, in those reports, or we can generate information from newspapers. Okay, some newspapers may have certain news about a firm. We can make a judgment about if this news or this news message includes a certain level of uncertainty or a certain level of positive information or negative information about the firm. we can measure the magnitude of positive level or negative level. Okay, or we can generate the sentiment of people in the community through Twitter posting or from Facebook. Okay, and we can also generate the satisfaction of the employees from the Glassdoor, like a website. Okay. Here is an example about the SEC filings. Okay, like we search the SEC filings of a firm through SEC editor engine, and we can see that if we search Walmart there, we get information about 8K, annual report, quarterly report, or proxy, or like annual meeting, like filings, or like other like documents. Those are all like qualitative information or text information that we can use. Okay. And if we open the annual report, we have a huge, very long like document. Okay. So in the past, we generate the numbers or quantitative data from annual report only. Okay. Like we like from the balance sheet, from the income statement, or from the other financial statement from the annual report. We only use a very small part of the annual report. But for all other part are text information or qualitative information that we could not use in the past, but now we can use them. Okay, we can use them now. For example, we can calculate the proportion of positive words in a certain document. Okay, we can first calculate the total words of a document, like annual report, maybe, for example, 1,000 words or 10,000 words, for example. And among those words, based on a list of positive words library, we can count the number of positive words in the document, for example, 20. Okay, so we can, based on those numbers, we can calculate the magnitude of positive information or positive sentiment using 20 positive words or the number 20 divided by the number of total words included in the document. Okay. And similarly, we can do it for negative words. We can do it for uncertainty words. Okay. And we can also calculate the allocation of different topics in a document. Okay. So what is the percentage of words or the content is related to risk management? What is the percentage of the content is related to like R&D, for example, or research? Okay. That percentage is a number, right? Like which is another way to convert the text information to a number. Okay. And also like what is the percentage of content is related to energy related? Okay. Mention about energy, mention about the climate, like a risk, or mention about the politics. Okay. Or we can combine the sentiment with topic allocations to check the attitudes of the firm towards each topic. Okay. For example, like there is a certain area of the firm's annual report talking about energy. How many positive words included in this part? Okay. And based on the number of the positive word, we can see that maybe like this firm has a positive attitude towards energy topics, like for this year. Okay. If they have many uncertainty words included in this energy section, probably like that shows shows that the firm is considering about more about the energy risk or energy related risk in the future year. Okay. And here is an example about the list of words. We currently have different libraries. Okay, we have libraries for finance, we have libraries for business, we have a library for social science also. It depends on like what areas are you focusing on. Okay, this one is a library for finance. Okay, because I'm in finance, so I provide an example like or word list for finance. So for example, first column are part of the word list, like or negative word list. Like for example, abandon. Abandon is a negative word, right? Or we can see other like abnormal, okay, like which is also a kind of a negative, like a sentiment, like a word, okay. And we also have like some positive, like a words with positive sentiment, like able. I'm able to do it, so it's a positive sign, right? Or like we have achieve, like we can achieve something, so achieve can be treated as a positive word, okay. And also like we have different other categories like uncertainty or constraining, okay. And when dealing with a text or a filing of a form or a text document, we can check all the words from document and comparing those words with the words in the list or in the library to see what's the percentage of positive words, what's the percentage of negative words, what's the percentage of uncertainty words, and then we can get some information that we could not notice through the quantitative data only. Okay, those are actual information that we can get or that we can apply in data analytics. And we can even treat the percentage number as an input variable in our model. Okay, which may also be able to provide some explanation power to our topics, for example, stock price, or like credit risk, or the probability of default. Okay, although it may not be possible like to find factors that can fully explain the variation of the stock price, but it can have some extra explanation power to the topics we are interested in. Okay. Okay, so those are the major content I want to include in my speech. So, like, do you have any questions about the machine learning or the application of machine learning in quantitative or qualitative data area?
Let me check online.
Okay.
I'm sorry.
Oh, there is I saw that there's a chart. Okay. Oh, there's no sound.
Oh, that would be bad.
Yeah.
So what program do you use to perform the analysis you talked about?
There are many choices. Like in my research, I majorly use R or Python. Okay, but in like for other programming languages or softwares, like they also have like other like packages or functions. Okay, for example, SAS, they provide a SAS Viva, which is a platform for doing like machine learning analysis. It's quite convenient, like or the user friendly. Okay, which is different from the the environment like R or Python. But I think, like for example, like there should be also like other languages can perform like machine learning functions. But for me, I majorly use R and Python.
Okay, I think that is all of the questions.
Okay.
Yeah, I have a couple of questions.
Yes.
The first one, machine learning or artificial intelligence is like a buzzword, the sought after kind of area for everybody.
Mm-hmm.
But as you're undergraduate student, especially in the business school,
Mm-hmm.
Machine learning or artificial intelligence due to them, even new. And also, we don't have like relevant classes offered by the College of Business Administration. So, what kind of stuff do you recommend for our students to study themselves or prepare for themselves before they graduate from college?
You mean the course materials or?
In the field of machine
Well, that's a very good question because currently, like there are many like information or materials about machine learning, but majorly many of them are research papers, right? Like so, for undergraduate student, I think as I know, there are some like training programs from some like program languages firms like SAS or like MATLAB. They have like training certification programs or like study materials or videos like through those companies and softwares or the coding languages. But it depends on what kind of like a language are like you decide to apply in the class or like during the analysis process. It depends. I mean, I think for undergraduate students, the first thing I think that the most important thing is to first understand the principle behind the machine learning. Why we call it self-learning process. Okay, as I mentioned, and the application of machine learning is in business area. And then I think if for some undergraduate students, if they are very interested in a certain area, for example, if some students are interested in like investment or asset pricing, probably like we can provide some materials about basic like machine learning techniques like model averaging, like not very complicated like algorithms, and so that they can apply like during the school time or during the class time. But to learn machine learning in like and then apply machine learning techniques in their daily life, first of all, they need to have a basic skill about coding first. Okay, so I think if they have some basic like a training or skills about coding in any like language or software, then like an introduction about very basic machine learning algorithm will be very helpful, because after that, like a student can learn like based on the principles by themselves.
Yes, thank you for your answer. But again, for undergraduate students, it's very difficult to find out where to start and how to start.
Mm-hmm.
So, if possible, can you just recommend us where to start and how to start? For example, of course, we have a bunch of different programming languages available. Like you mentioned, Python or R, even SAS, and it can be candidate.
Mm-hmm.
But for example, when it comes to science, even though our college has the license with the SAS programming, but you have to be here to use the SAS software. So I cannot install SAS software on my local computer, which means I cannot practice myself, right?
Mm-hmm.
So there is a kind of limitation. So it's more than language. So any language is okay. I understand that.
Mm-hmm.
But personally, if you recommend any one of the languages, which language might be the best language for our students just to begin with? And also, can you recommend any kind of a specific website or place where we can start?
Okay.
Because it's kind of a difficult. No, we can choose any languages, we can go anywhere. Yeah, that's true. But if you have any information, just to share with us.
I think for SAS, that question is a very good question, because SAS is not a free software, right? It's very expensive. Like in fact, although like SAS Viva is quite user friendly, like we can like develop some graphs like through that platform and to finish the machine learning analysis. But again, like it's expensive and we could not have the access anywhere. Okay. So my recommendation is more like other like free softwares or languages like R. Like if I recommend, I will recommend R, because comparing with other program languages like Python or C++, R is more straightforward because there are many existing like machine learning packages for R, like online or on the internet. So generally, like if you search on Google about R package and the machine learning, then you will find like some existing packages about like, for example, random forest or some certain like machine learning techniques. So we do not construct the package by our own. We don't need to do the coding. We just need to call the functions like in R, and then we can use it, which is quite convenient. For Python, we can also do that, but Python is more, I mean, based on my understanding, I'm not an ECS major, so like a personal opinion, R is easier to apply, like for students, especially for like undergraduate students, like in College of Business. Okay, I also like put some R programming information like or knowledge in my own class. So and another reason is because R is free. Okay, so SAS is very expensive, but R is free. It's a free software, and we can download it anywhere. Okay, like on our own computers and on the school computers, and then we can use it anywhere. So basically, even we go to the even our students go to the real industry in the future, no matter like what kind of firms or companies they are working for, if they are working for some like huge or giant companies, probably they have the access to SAS or like other languages. But if not, it will be fine, like because we can use R for free anywhere. Okay.
Okay, one more question. Actually, I have a actual question to ask, but I don't want to use it in the whole Q&A session for myself. So my second question and last question, can you give me the name of the dictionary?
Dictionary.
Yeah.
This one is from this dictionary is created by two finance professors in Notre Dame, like a university, like Notre Dame University. So basically, they are doing the textual analysis like at a very early stage, and
So which means it's not the up-to-date dictionary, or it's not the
no, because like the dictionary has already been created like at around 2016, I think.
So do you have a like up-to-date dictionary?
They are. I think they are adding some actual words like year by year. Like they are updating the version of the dictionary, but they first apply those dictionary in their own research, and then like they further develop their own dictionary, and there are also many other dictionaries. I remember like there is a Harvard, like some dictionaries like existing, like probably I need to Google them, like, but there are a lot of them. Okay, it depends on what kind of like areas like you want to focus on. If you want to focus on the finance area, probably you can like download the dictionary like through the website of the two finance professors, and I can send you the link.
Okay. Thank you.
Do you write your own program with R or Python to do such analysis?
Thanks. I'm refreshing my memory if I did like a own coding. Okay. Currently not. But I know that if we we do the self-coding for our own packages, it can be more precise. I mean, when I talk with other researchers, they say like some of them or some of the finance professors, like they are conducting their own packages or coding packages by themselves, and they can reach a more precise result in their research. But for me, at current state, I didn't try that. Okay? Like I'm applying the existing packages online, through R or Python. Yeah, but I mean for some finance researchers or of course for computer science researchers, they are conducting their own packages, of course. But I'm not a computer science specialist, so I borrow the knowledge from computer science area and to apply in finance area.
So if I add a little more on Dr. Wang just comment, I think there are two reasons why we do not do that. First, it will take some time to code or create package. Second, we cannot trust basically. We cannot trust the credibility. So if anybody just develop or create a certain package, we can easily use it, but we have to be careful. Those packages should be tested by other researchers, and then many researchers already own this package. So anybody using this package, then we can just use it without any question. But if any packages come out for the first time, but apparently this is clear, anybody can contribute their work into our community. So personally, I cannot trust at the beginning. So it'll take some time.
Have you used JMP? If so, thoughts?
JMP, I used it, but not very often, many years ago. But I'm not very familiar with it. Yeah.
So can you show us an example of the program you used and the analysis result?
I do not have the analysis result on hand, but I can show a working paper of mine. Basically, it is available online. Could I
Yes.
quick to go to the
There you go.
okay, so let me see. Okay.
Now we wait for VSU Internet.
Okay, I'm searching my own, or I'm searching myself, through the SSRN. So yeah, basically, this is my. Oh, this is one of my working paper. Oh, how could I
For
make
some
it
reason,
larger?
it's not showing on the.
Oh, I see.
Nope. Oh, I figured it out. There you are.
Yeah. Here, this is my one of my working paper, which is applying the deep neural network on the forecasting work of firms' earning or companies' earnings. Okay, and then further using the earnings to calculate the implied cost of capital of a firm. Okay, basically, it's free to download and access. Still a working paper, but basically we I already have the major result on it. So when using the deep learning or deep neural network, my own model can reduce the bias of earnings forecast of a firm, and then can be more consistent to the actual earnings. Okay, and also through the analysis, basically the earnings per share estimation from the machine learning algorithm can provide actual explanation power, even when control the earnings per share from financial analysts or from the human beings. Okay, so if I regress the real earnings on the earnings forecast from the human beings or financial analysts of the brokerage, and the earnings per share of a machine, a forecast of the machine. Then both of them can provide explanation power, but we can see that basically the estimation from the machine learning can provide extra explanation power. Okay, and basically this is one example of the application of a machine learning algorithm in finance area. And basically, if we want to find some like package, like for example, we can search R package, random forest, for example, and we can find some package about different machine learning algorithms already existed online, like and available to use for people not in like computer science area. If you want to like directly use the machine learning algorithms, like me, like to another area or in a social science area, you can directly use those packages, which is existing like resources. If you want more precise estimations or a model with a better performance, as mentioned, like in the previous questions, you can develop your own algorithm by yourself, or write your own package by yourself. Especially for like a computer science specialists or like experts. Okay.
Pull back up the questions. There they are. And so, do you just use matching words to judge the sentiment? How do you judge the tone of the expression? For example, a sarcastic tone.
Yeah, basically now there are different types of textual analysis techniques. Majorly the most straightforward one is checking the words. But as I mentioned, like they have different a list of words libraries for different purpose. Okay, so basically we can for tones or other purpose, if there are some existing libraries, we can directly apply, or if not, when doing the research, there are some people constructing their own library by themselves, when doing the research, in business or finance. So it depends on your needs or demands, or if there is an existing library or existing list of words from some top experts, that would be fine. We can directly cite their paper, but if not, we can construct our own a list, and basically to see if other people will accept our list of words.
Okay. I think that is all of the online questions. Oh, it was a comment.
Creating a dictionary?
Yes. Hold on, I'll pull it back up. I created a dictionary. It took 3 people in a good part of a year. Do not recommend.
Yeah, basically creating a dictionary or write a programming package is very it consumes a great effort. Okay, basically those words are, in my opinion, those words are achievements. I mean, which will benefit many people. I mean, but it needs great effort, to work on those dictionary or package things. Yeah. Okay. But of course, the performance for the models will be much better. Of course. Okay.
Just a quick question. It's almost 7. Just a quick question. You talked about text analysis, and you show us a dictionary.
Yeah.
So suppose that we have undergrad students who want to analyze, for for example, Dean's message available on website. In the, and so they want to know how college deans address issue related to, for example, equality or diversity, and the sort of research topics. So for undergraduate students, well, what is the first starting point? They have dictionary. They have they can explore a website. Now, what should be done for undergraduate students? What's next step?
Basically, when using the dictionary to do textual analysis, it is a measure about the attitude from the document. Okay? For example, we have for example, as you mentioned, like the equality things like from different schools. For example, we have a document from DASA, we have a document from UGA, or some document from other schools, for example. And if we have a dictionary, we can calculate the proportion of the words for those documents which are related to equality or which are related to certain topics, and to measure if, or to see if the people or the writers of those documents put enough effort on this certain topic.
So our undergraduate students need to learn technique about how to scroll. So it should be
basically, if we need to do a larger, big data analysis, probably we need to know how to scrape the data from the internet.
Because there's a kind of a barrier, and in order to learn any computer programming language. It's not that easy. So I just wonder if there's any user-friendly way to.
I remember we have a data set from our library, including the different section of annual report of each firm. So basically, for people from our school, we can have access to that data set. And to download the, for example, the risk factor item from the annual report of 100 firms or specific firms, we download them to the local area in Excel, and then we can do the analysis. So by using some data vendor or some data firms services, we don't need to do the data scraping from the website. For our school, we have that. What's the name? I forgot the name, but I know we have it. I will check it. No, for our university. For our university, we have that. I can check it now. I also forgot the word, the name of the data set. But let me see.
So we can think of that question. We can think of this way, because we don't want to do everything at the same time. For example, in order to do a data
resources, data sets, database,
stuff, right? But given time, we won't be able to learn everything from web scraping, and then pre-processing of the word with the text data, and then analyzing the data, and then finally we have to visualize the data. So those are the steps to
this one,
text analysis or text analytics, but we cannot learn everything at the same time. So if you want to focus on data analytics, then just focus data analytics. Don't worry about web scraping, for example. So if we have a data, then we can do data analysis. So we can find some data available on the website or from some kind of platform. So simply download the text data, and then we can learn how to apply the text analytics stuff to the real data. But if you're interested in web scraping, apparently you have to learn how to do web scraping, how to program web scraping. But personally, I don't recommend you to learn web scraping because website is ever changing. Almost every day they keep changing. So once they change the website, it's very difficult to run your web scraper again. You have to fix so many things. And also you have to target like in a certain platform or community where we can have a lot of data. For example, Reddit.com, you know about the Reddit.com, right? Then we can have a lot of data set. But if you want to track down individual website, this is kind of a stupid decision. We cannot develop web scraper for individual website. It's time consuming. It's not cost effective.
Yeah, so I just found the name of the database, which is Bench. Basically, like all the ResU folks can have the access to this data set by using like the ResU email address. Basically, this data set will can provide the financial data of firms, okay, like firms on like in the S&P 500 or many other firms. And the amazing thing is this data set can provide the tax data, or the 10K or the annual report, the data like in each section, in each like a part by part. For example, if we go to the SEC editor, we download 10K is a full document, right? But if we download the data from Bench, we can download a certain area information. For example, we can download the risk factors area or content from the annual report for a certain firm. Okay, and we can save those information in Excel. Okay, which is quite convenient for us to use or to collect the data from multiple firms or like, for example, hundreds of firms. Okay. This one is quite useful. I use it in my previous research project, like and we all have access to this one. Yep. So
Okay.
Yeah, that's all for the speech. And again, thank you very much for coming, and thank you very much for the questions. And if you have any further questions, feel free to email me or like contact me. Okay, like at another time point. Okay, and thank you very much.
Please consider joining DASA if you're a student. Okay, and then